This is geometry, working on semester number 2 exam review. We're going to talk about Unit 6. One thing we want to talk about is how C is the midpoint of GJ. We need to point that out. And let B be the midpoint of HJ. So if we know those are the midpoints, then we know that BC is the mid-segment of triangle GJH. And if it's the mid-segment, then we know that BC is going to be half of HG. And if HG is 7p minus 1 and BC is 4p minus 3, then we can write an equation. Now I can't take half of 7, I can't take half of 1. So what I'm going to do is multiply by 2, that's going to cross out, and multiply by 2, which I have to distribute in. When I distribute this in, I'm going to get 8p minus 6. 2 times 4 and 2 times 3 to equal 7p minus 1. Then I can start to bring over my values, and I get p equals 5. So that helps us calculate what this BC is going to be. So BC equals 4 times 5 minus 3, which is 20 minus 3, which is 17. Here we're going to talk about perpendicular. So we have this point that is supposed to be out here at 8 comma negative 4. Just a sketch. We have this other line that is down here at negative 17 with the slope of up 4 over 3, up 4 over 3. So if I want my values to really match up well, maybe I'm going to make my slope look a little bit more like 4 over 3. So we're going to make a line that's going to go through 17 and through our point, and it has to be perpendicular to this line. Oh, take that back. I'm sorry. It doesn't have to go through 17 here. I'm just drawing a whole bunch of stuff. We can go back to our original line. To be perpendicular to it, we don't know what this y-intercept is. I implied that it went through 17, but of course it doesn't go through 17. So we have this line. This is the equation that we want to figure out. What's the equation of that line? Perpendicular to this line. So what we're going to do is plug in. We know that the slope of our first is negative 4/3. Our perpendicular slope has to be the opposite reciprocal. The opposite reciprocal is perpendicular. So that makes this perpendicular. If one slope here is negative 4/3, then this slope would have to be 3/4. So we know that we're going to have y equals mx plus b. So our y value is going to be negative 4. Our slope is going to be 3/4. our x is going to be 8 plus b. So when you multiply here, you get 24 divided by 4, which is 6, plus b, minus the 6 across. So you get negative 10 equals b. So now I know my equation of this line. It's going to be 3/4 x minus 10. So that means it's crossing, this line's crossing at negative 10, which is below negative 4, which is above negative 17. Here we have two lines. We have negative 4, 5, negative 1, 1. We have 5, 1. We have 8, 5. So we have to determine if the lines are parallel, perpendicular, or neither. Well, my little sketch kind of makes them look perpendicular, but let's do our calculations to determine that. y2 minus y1, x2 minus x1. So we're going to take our first point, our y is 5, our y is 1, our x is negative 4, our x is negative 1. So that gives us 4 over negative 4 plus 1, which is 4 over negative 3. So that seems to have a slope of negative 4/3. Let's check out our second line. So our y is 1, our y is 5, our x is 5, our x is 8. That gives me negative 4 over negative 3, which is a positive 4/3. So look at those. Those are opposites, but not opposite reciprocals. So it's considered neither. Not opposite reciprocals. They're not reciprocals. All right, looking at number 4. We have our points. Negative 2, 3. Negative 5, 7. Three, 6. And 6, 2. We want to show that the diagonals bisect each other. To bisect each other, they have to have the same midpoint. x1 plus x2 over 2, comma, y1 plus y2 over 2. So we're going to use points B and D. So x1 plus x2 over 2 and y1 plus y2 over 2. That's going to give us 1/2, and that's going to give us 9/2. So that would be 0.5 and up 4.5. 1, 2, 3, 4.5. So that's supposed to be the halfway distance of that diagonal. So we're going to check the other point, which is AC. So x plus x over 2 and y plus y over 2. We get 1/2, comma, 9/2. and those are the same. They have the same midpoint. So a quadrilateral with diagonals that bisect each other is a parallelogram. So we know it's a parallelogram. We just proved that because the diagonals bisect each other. They have the same midpoint for each diagonal. They land in the same spot. Okay, we're going to find the slope, where our slope formula is y2 minus y1 over x2 minus x1. So we'll call this x1, y1, x2, y2. We just plug in our numbers. 2r minus 4r and negative 6m minus 2m. That's going to give us negative 2r over negative 8m, and that reduces the 2 and the 8 can reduce to 4. So we have r over 4m. That would be our slope between points with these coordinates. The midpoint. We've already talked about the midpoint formula, but that's when you add the x's divided by 2 and add the y's divided by 2. So our 2m plus our negative 6m divided by 2, and our 4r plus our 2r divided by 2. That gives us a negative 4m over 2 and an 8r over 2, which gives us a final answer of negative 2m comma 4r. Oh, I'm sorry, that's plus. So this would be a 6. Hopefully you caught that. Alright, I'm glad I caught it. Okay, then the distance. We haven't done distance formula yet. Distance is x2 minus x1 squared plus y2 minus y1 squared. So I plug in my values. X2 would be negative 6m minus 2m, and 2r minus 4r. That's going to give us negative 8m, that's going to be squared, and that's going to give us negative 2r, that's going to be squared. So that's going to give us 64. 8 times 8 is 64, m squared, and 2 times 2, even negative 2 times negative 2, is 4. R and R is R squared. You cannot take the square root of any of that. Because of the plus, you can't get into it. Okay, last example. We have the point at negative 2, 4. 3, 5, 2, 0, negative 3, negative 1. Give the most specific name. So the first thing we're going to do is look at some slopes. So the slope of AB, is up 1 over 5. The slope of BC is down 5 over 1. the slope of DC is, you could say, down 1, backwards 5, which is the same thing as 1/5. And the slope of AD is up 5 over 1. So we see that these two match exactly. That was down 5, backwards 1, which is 5 over 1. So these are the same. So we have two sets of parallel sides. Two sets of parallel sides. That's going to make a parallelogram. So is the parallelogram opposite reciprocals? So when we look at the sides right next to each other, 1/5 and 5/2 are not opposite reciprocals. The consecutive sides are not opposite reciprocals. They're reciprocals, but not opposite reciprocals. So not perpendicular. And then we could look at the diagonals to see if they're perpendicular. If they're perpendicular, then this is a rhombus. We don't have to look at side lengths. So the slope of AC is down 1, 2, 3, 4, 1, 2, 3, 4, down 4 over 4, so that's -1. And the slope of BD is up 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Opposite reciprocals. So diagonals are perpendicular. These diagonals form right angles. So we have a parallelogram with perpendicular diagonals, but not perpendicular sides. So it's a rhombus.